So for example 2 from section 2.5, we're going to look at the limit as x approaches pi over 2 of tangent of x, all that over secant of x. And if we remember the graph of tangent of x and the graph of secant of x, those both are going to have infinite discontinuities at x equals 2. Let's open up Desmos real quick and take a look at that. Let's see, Desmos, and let's just graph stuff. So we're going to say what is tangent of x. So pi over 2 falls here. We have kind of this asymptote going on there. And let's see if we can do secant of x. And so we can see secant of x, this blue line, also at pi over 2, falls up there. And then these two come back. So we have this infinite discontinuity at x equals pi over 2. So that's not good. And what it tells us is since we have a infinite discontinuity at pi over 2, we're in an indeterminate form. If we try to plug pi over 2 in for these, we get things breaking down. If we look at what's happening as we approach pi over 2, we get the form infinity over infinity. So if we try to plug pi over 2 in for these, there's vertical asymptotes there, and we have these infinite stuff trailing off to infinities, which is going to be an indeterminate form. So what we're going to do is we're going to try to algebraically manipulate this till we can get something to cancel out. And then if we can get something to cancel out nicely, then we can hopefully make good things happen. So we're going to look at the limit as x goes to, we're going to cancel it so we don't need the limit on this part. We're just algebraically working with this. So we got tangent of x, all that over secant of x. And let's take these down to those basic trig functions. Tangent is sine over cosine. And secant is 1 over cosine. Okay. I'm going to do, keep the top part the same, and we're going to flip and multiply it by the bottom to kind of get rid of these complex fractions. So I'll have sine of x, all that over cosine of x, times 1 over cosine of x will flip. This will become a so instead of dividing, it becomes a multiply, and we have cosine of x over 1. So these cosine of x's will cancel. This will leave me with sine of x. And so tangent over secant of x is the same as sine of x as long as cosine of x. So those two things will be the same as long as cosine of x, the part that canceled out, is not equal to 0. So we say this happens where cosine of x is not equal to 0. And if we think about it, well, what happens at pi over 2? Well, cosine of pi over 2 is 0. So this right here and this right here, they're equal everywhere, except at places where cosine of x is 0. Then they have some issues there. So if we're looking at limit as x approaches pi of this, limit as x approaches pi over 2. Cosine of x is 0 at pi over 2. So if we're a little bit to the right or a little bit to the left of pi over 2, tangent of x over secant of x, since a little bit to the right of pi over 2 and a little bit to the left of pi over 2 won't make cosine of x 0, then this expression here will be the same as the sine of x expression. So we can use that and say, all right, this will equal the limit as x approaches pi over 2 of sine of x. Sine of x from those base functions we were given back in section 2.4 We know sine of x is continuous. It's continuous at x equals pi over 2. So we can evaluate this by just substituting in and say, what is sine of pi over 2? And if we think about sine of pi over 2, that is going to be 1. It's the y value at pi over 2, which will be 1. So again, we had an indeterminate form. We had to verify we're in an indeterminate form. When you are in an indeterminate form, there'll be some common factor that you can cancel algebraically. So we went through and did that. The leftovers will be equal. So this will be equal to that. Everywhere except for the places where the bottom part that canceled out was equal to 0. And we verified that this limit would make cosine of pi over 2 would be 0. But if you're a little bit to the left and a little bit to the right, which is what the limit cares about, then you're not at a point where cosine of x is going to equal 0. Therefore, this tangent of x over sine of x will be the same thing as sine of x there. And that allows us to say the limit of this complicated thing equals just the limit of sine of x. And then furthermore, we know sine of x is continuous at x equals pi over 2 because it's continuous everywhere. So that lets us evaluate it by substituting the pi over 2 in for the x. And we get a equals 1. Oops.